Volcano. First of all, let's learn what a volcano is. A volcano is an opening on the surface of a planet or moon that allows material warmer than its surroundings to escape from its interior. When this material escapes, it causes an eruption. An eruption can be explosive, sending material high into the sky, or it can be calmer, with gentle flows of material. In the world, Indonesia, Japan, and the United States are considered the three most active volcanoes in descending order of activity. So, how many types of volcanoes are there? In the frequency of eruption of volcanoes, they are divided into three categories. Active volcanoes are volcanoes that have had recent eruptions or are expected to have eruptions in the near future. Dormant volcanoes no longer produce eruptions, but might again sometime in the future. Extinct volcanoes will likely never erupt again. Now we'll figure out what causes volcanoes. Volcanoes occur when material significantly warmer than its surroundings is erupted onto the surface of a planet or moon from its interior. On Earth, the erupted material can be liquid rock, ash, cinders, and/or gas. There are three reasons why magma might rise and cause eruptions onto Earth's surface. Magma can rise when pieces of Earth crust, called tectonic plates, slowly move away from each other. The magma rises up to fill in the space. When this happens, underwater volcanoes can form. Magma also rises when the tectonic plates move toward each other. When this happens, part of Earth crust can be forced deep into its interior. The high heat and pressure cause the crust to melt and rise as magma. A final way that magma rises is over hotspots. Hotspots are exactly what they sound like, hot areas inside Earth. These areas heat up magma. The magma becomes less dense. When it is less dense, it rises. Each of the reasons for rising magma are a bit different, but each can form volcanoes. Do you know what effects volcanoes have? A volcano eruption is one of the most impressive events in the planet. The type of effects of volcanoes depends on the size of the eruption. Earthquakes, hot springs, fumaroles, mud pots, and geysers often accompany volcanic activity. Several eruptions during the past century have caused a decline in the average temperature of the Earth's surface of up to half a degree for periods of 1 to 3 years. Sulfur dioxide from the eruption of Volcano Putina probably caused the Russian famine of 1601 to 1603. Volcanoes have had some significant consequences on human history. A volcanic winter is said to have taken place around 70,000 years ago after the super eruption of Lake Toba on Sumatra Island in Indonesia. It had global consequences, killing more humans than alive and creating a population bottleneck that affected the generic inheritance of all humans today. The massive eruptive event which formed the Siberian Traps, one of the largest known volcanic events of the last 500 million years of Earth's geological history, continued for a million years and is considered to be the likely cause of the Great Dying about 250 million years ago, which is estimated to have killed 90% of species existing at the time. The 1815 eruption of Mount Tambora, Indonesia, created global climate anomalies that became known as the year without a summer because of the effect on North American and European weather. Agricultural crops failed and livestock died in much of the northern hemisphere, resulting in one of the worst famines of the 19th century. Erupting volcanoes can cause acid rain. What do we know about this phenomenon? Sulfate aerosols promote complex chemical reactions on their surfaces that alter chlorine and nitrogen chemical species in the stratosphere. This effect together with increased stratospheric chlorine levels from chlorofluorocarbon pollution, generate chlorine monoxide, which destroys ozone. As the aerosols glow and coagulate, they settle down into the upper troposphere, where they serve as nuclei for cirrus clouds and further modify the Earth's radiation balance. Most of the hydrogen chloride and hydrogen fluoride are dissolved in water droplets in the eruption cloud and quickly fall to the ground as acid rain. The injected ash also fall rapidly from the stratosphere. Most of it is removed within several days to a few weeks. Finally, explosive volcanic eruptions release the greenhouse gas carbon dioxide, and third, provide a deep source of carbon for biogeochemical cycles.